Hi, everyone, and welcome to Secure Your Workloads on AWS with Zscaler. Today's webinar is sponsored by Zscaler and produced by Actual Tech Media. My name is Keith Ward. I am with Actual Tech Media, as you might have gathered, and I'm truly excited to be your moderator for today's special event. Before we get to the content, however, I do need to cover some housekeeping items for you. The first thing I need to mention is that we want your questions. Put them in the questions tab in your webinar control panel for our experts. At the end of this session of the presentation, we're going to do some Q&A based on those questions, so keep them coming in. Now, that Q&A panel is also the place to let us know about any technical issues you might be experiencing. A browser refresh will fix most audio, video, slide advancement issues. So try doing that first and then give it another refresh if it still doesn't fix it. If 2 refreshes don't cure things, let us know and we will help you out. Okay, next up, right next to that questions tab is the handouts tab. Now that handouts section is really important, and there are some essential resources that I urge you to check out right now. And first of all, over there, we have got 5, count them, 5 handouts from Zscaler. Now they include a buyer's guide, a SANS product review, several zero trust related handouts, and a lot more. So a ton of great stuff from Zscaler that is included absolutely free. Get that from the handouts section now. In that section, you'll also find a link to the ATM Decisions Group, which is a panel of IT decision makers that you can apply to join to participate in some more in-depth events and other opportunities. You'll also find a link to the ATM Event Center, which has our calendar of upcoming events just like this one. And finally, at the end of this webinar, we are going to be awarding a $250 Amazon gift card to one lucky registrant who might be you. Now, remember that you have to be in attendance during the entire live event to qualify for the prize. The official terms and conditions of the prize drawing are also in that handouts section right there at the bottom. Just scroll over and you'll find the link with the details there. And with that, everyone, why don't we get to today's main event? It is my pleasure to introduce you to our presenters, Henning Els, a senior solutions architect with Amazon Web Services, and Aaron Royens, principal technical product specialist with Zscaler. They are ready to go. Henning is up first. So Henning, the floor is yours. Take it away.
Also, thank you everyone for joining the class today. So my name is Henning Els, and I am a solutions architect here at AWS. I have been with AWS for the last 5 years, and I'm calling in here from beautiful wine country in Northern California. So I'm very excited to be here. I'm thrilled to be co-presenting with Aaron Royhan from Zscaler, talking about how to secure your workloads running in the cloud. So with that, Aaron, did you want to do a quick intro?
Sure, thanks, Henning. Hey, folks, my name's Aaron Royens. As Henning said, I'm a product specialist at Zscaler. I focus on workload protection, specifically workloads that operate within AWS. I've been with Zscaler now for 3 or 4 years. Prior to that, did a lot of SD-WAN work and whatnot. And I'm calling in from the beautiful state of Tennessee right now. So back to you, Henning.
Fantastic. Thank you very much, Aaron. All right, so with that, why don't we get started? So today we are going to take you through some of the challenges, services, and best practices that customers face when moving workloads to the cloud. For anyone who decides to move to the cloud, the first thing that we always hear them say is, well, let's talk about security. Keeping our data and our environment secure in the cloud is a non-negotiable. We have a saying at AWS that security is a day zero task, and we design solutions with security built in from the start. The first challenge that we see people run into when they want to move workloads to the cloud is that security can be an innovation decelerator. We want to reverse that belief by implementing security practices and tools and automation ensuring security is seamlessly integrated into the development lifecycle. For example, AWS services like Security Hub and Amazon Inspector automate security assessments and enable CI/CD pipelines with baked-in security checks. This empowers developers to innovate faster and with confidence, knowing security isn't a separate hurdle to overcome. We also know that skilled cloud security professionals are in high demand, and we want to make optimal use of their time. By providing the right tooling and the right level of automation, we are freeing up these expensive specialists to focus on strategic initiatives and work on the differentiated work. Later in the presentation, we're going to learn how Zscaler provides security solutions to help you towards this goal. The cyber threat landscape is constantly evolving, and new vulnerabilities and attack vectors emerge daily, if not hourly. We need to stay ahead of the curve. To do this, we need security solutions that are intelligent and adaptable. AWS Threat Intelligence provides continuous security updates based on the latest threat data. This empowers customers like yourself to implement preventative measures and mitigate risks before they become exploits. And then finally, if we look at the data privacy regulations, they are becoming increasingly complex. Organizations need to comply with industry standards like HIPAA and GDPR to maintain customer trust. AWS provides a comprehensive suite of compliance tools to simplify this process. For example, AWS Audit Manager streamlines compliance audits, while Amazon Macie helps you identify and classify sensitive data. These tools empower you to demonstrate compliance and build trust with your customers. So going back to the point about security being an innovation decelerator, this is a great picture of the challenge that organizations face today. They have to choose between one or the other. They can either move fast or they have to be secure. And this is due to the overly manual security processes that are in place today. InfoSec is often forced to slow things down to human speed so that they can ensure the security of the organization is implemented correctly. Today, through automation and tooling, we are able to change the story. It is possible to automate many of the basic security tasks like patching, and with the right tooling to gain the visibility needed to accurately identify and monitor critical assets and data. With the cloud, all of this is made easier so you can stay agile while maintaining and, in many cases, improving your cloud security posture. By providing highly integrated logging and monitoring, as well as integrated tools to automate security functions, organizations can innovate quickly and maintain their security posture. So looking at the next slide here, customers need to be confident that they are migrating and building on a secure cloud foundation. They're looking for ways to move security from something that is tacked on at the end of a process, slowing down innovation, to something automated and integrated into every step of development. This allows security teams to focus their expertise on tasks with the highest value to the business. And finally, customers need trusted partners like Zscaler to extend the benefits of the cloud with innovative technology, services, and expertise, making sure that their workloads are secure from end to end. Looking at the AWS infrastructure, imagine a global network of data centers guarded by a world-class security expert, constantly monitoring and updating with the latest threat intelligence. That is the reality that you get with AWS. We invest billions annually in state-of-the-art infrastructure so you can focus on building without worrying about the underlying security infrastructure. Security shouldn't be a manual burden slowing down your development cycle. With AWS, security becomes an integrated partner. Our suite of automated tools like Amazon Inspector and Security Hub continuously scan your environments for vulnerabilities, freeing you to innovate faster. These automated guardians identify and address issues before they become problems, letting you ship secure code faster. Security isn't just about the physical data center, it's also about protecting your cloud resources and the data that lives in it throughout its entire journey. AWS offers a comprehensive security toolkit with fine-grained access control and encryption at rest and in transit. This multi-layered approach ensures your data is secure no matter where it travels, giving you the confidence to operate cloud workloads securely. AWS also makes a strong case for being one of the most secure cloud providers around, especially for network security in and around zero trust. Customers benefit from a cloud and network architecture built to meet the requirements of the most security-sensitive organizations, including governments and financial services and healthcare. Security is the central pillar around which AWS infrastructure and services are designed and managed. We cannot possibly cover all of the security measures offered by AWS today, but here are some of the callouts. Security is built in. AWS takes care of the underlying infrastructure security. You don't have to worry about hardware maintenance or patching vulnerabilities in the network itself. We have a vast team of security experts constantly monitoring and updating our systems. Another callout is that AWS gives you granular control over your network environment. Security groups act like firewalls for individual resources, letting you specify exactly what kind of traffic can flow in and out of that resource. As a final callout, AWS offers tools like Amazon GuardDuty that uses advanced threat detection to identify suspicious activity in your cloud workloads. This can help you catch and respond to security incidents quickly. Using the AWS security services along with Zscaler's suite of products give you the confidence you need to run workloads in the cloud. We all agree that cloud security is crucial, but managing it all manually can be a real headache. That's where automation comes in as your secret weapon. Automation is a critical component to be successful with security. Some of the benefits of automation are that it allows your most valuable humans to spend their limited time on the highest value tasks. It also reduces human error. It optimizes incident response times. It allows you to scale your security best practices across the organization. And finally, the last benefit for automation is that it helps you to stay compliant. Cloud security regulations are constantly evolving, and automation helps you to stay on top of compliance by automating tasks like security audits and configuration checks. AWS provides organization-wide controls that automate infrastructure and application security checks to continually enforce security and compliance controls. Automation isn't a magic bullet, but it is a powerful tool to streamline your cloud security. It lets you work smarter, not harder, keeping your data and applications safe and secure. Let's face it, securing your workloads in the cloud can feel like a never-ending puzzle. You're piecing together different tools, following complex step-by-step guides, and hoping it all adds up to a truly secure environment. At AWS, we offer a comprehensive approach, an end-to-end security that takes the complexity out of keeping your workloads safe. We do this by building security into every AWS service. AWS offers over 300 security services and features built right into the AWS platform. From encryption and access control to threat detection and incident response. Think of it like a security toolkit so vast that you will have the perfect tool for every job. It doesn't stop there. We know security isn't a one-size-fits-all situation. That's why we have a thriving partner ecosystem, of which Zscaler is a shining example. We are going to hear more about Zscaler product after the following slide. This may be familiar to some of you, but AWS employs a shared responsibility model for security. We like to say that AWS looks after the security of the cloud, and customers look after the security in the cloud. When we say AWS takes care of security of the cloud, we mean that AWS is responsible for protecting the infrastructure that runs all of the services offered by AWS. This infrastructure is composed of the hardware, software, networking, and facilities that run AWS cloud services. When we say that customers take care of the security in the cloud, we mean that customers are responsible for ensuring their workloads running on AWS. This includes everything from hardening the guest operating systems running on EC2 instances to ensuring their workloads have proper authentication and authorization. Along with this is ensuring that workloads, communication, and configuration is secure, and this is a great transition to where Zscaler shines in the industry. With that, I would like to hand it over to Aaron Royans, Principal Product Specialist, Zscaler. I thank everyone for being here. Aaron, over to you.
All righty. Thank you, Henning. All right, so securing traffic or securing the cloud is the job of AWS, but securing traffic in the cloud or securing your cloud workloads that are inside of AWS is the job of Zscaler. Now, how do we do that? Now, in order to answer that question, let's take a step back here and look at Zscaler as a whole. So if you're not aware, Zscaler is we own and operate the largest security cloud in the world. We operate about 150 data centers worldwide and process several trillion transactions per month. That's trillion with a T. So we've got a lot of traffic that goes through our cloud. It's a purpose-built cloud that's designed for security. It's designed to take our customer traffic, process that traffic in a scalable and efficient way, and then send that traffic to wherever the ultimate destination is. Now, historically, Zscaler has been focused on user traffic, right? So the idea would be I can be a user anywhere in the world, and there's always a data center, a Zscaler data center that is geographically proximate to me that I can send my traffic to and get it inspected. So whenever I crack open my laptop or I open up unlock my phone or unlock my tablet, those devices will automatically send traffic to the nearest Zscaler data center, where we will process that traffic for them and keep them secure. Now, again, historically, we focused on the user side of the house, but we had a lot of customers that came to us and asked us, hey, this whole security cloud that you folks operate, this would be great to augment security within the cloud itself, right? Within AWS, for instance. So how can I secure my cloud workloads using Zscaler? Right? And that's really where Zscaler Zero Trust for Workloads comes in, or Zscaler Workload Protection. The idea is we're going to take the traffic from your cloud workloads. Now, these might be EC2 instances, they could be Lambda scripts, they could be containers, really anything with an IP address that is sitting inside of AWS. Anything that generates traffic, we can take that traffic and process it within our cloud. Now, so you'll see there on your screen, you can see there kind of in the middle, the Zscaler Zero Trust Exchange. That is a representation of our cloud. Now there's two main use cases that we can support here. We're going to dive into each one of these as we go, but one is more of the traditional workload to internet use case, right? So getting traffic from your workloads out to the internet in a secure fashion, making sure that any traffic coming back from the internet is secured. We're not downloading anything that would be malicious into our workload, and then a workload to workload use case. So any workload that needs to communicate with another workload, whether that be another workload within AWS, another workload within another cloud, a private cloud, anything like that, we can also help you secure that. But the way we do that is to insert ourselves into the middle of that transit, to that transit path. Right now, The cool thing about this is our security model, since we're inserting a common security element in our cloud into the transit path here, we can keep things very, very consistent for you. So you have a very consistent security policy across all of your organization that stretches from users to IoT devices to AWS cloud workloads. You name it, we can secure it using the same cloud, the same security policies, and the same known common interface. Right. So that kind of obviously reduces the operational burden on IT staff and things like that. So IT staff, you don't have to learn a bunch of different interfaces. You don't have to learn a whole bunch of different firewalls and a whole bunch of different, different point products to handle various use cases. Instead, you can leverage our cloud to do that for you with a common interface that stretches across multiple use cases. So let's dive in just a little bit to a couple of these use cases. The first one is, like I said, kind of the bread and butter use case, which is workload to internet. Now, Zscaler workload protection. You might be asking yourself at the moment, how do we deliver this? Okay, so how do we get your traffic from the cloud workload? How do we get it from there to our cloud for processing? What's that picture look like? So down in the lower left-hand corner of your screen, you can see two little blue icons there that are sitting just north of the application icons or your workloads, for lack of better words. Those little blue icons represent what we call a Z connector. Some people have referred to them as cloud connectors, but we'll call them Z connectors here. So for Zscaler connectors. The idea behind them is they are a purpose-built gateway function for you as a customer. So you can deploy these Z connectors inside your AWS environment, and any traffic that you send to these Z connectors will automatically be transported to our cloud. So our appliances will take care of encrypting that traffic, intelligently forwarding that traffic to the correct Zscaler data center. We'll manage things like high availability in case we start to see issues on with certain circuits or internet paths. So we can automatically switch that traffic over to a better path. But that's the job of Z connectors, or cloud connectors as they used to be called. And again, we would insert those inside your AWS environment, and any traffic that you point at those Z connectors would be forwarded to our cloud. Now, what's unique about this solution, what's pretty cool about this, is these Z connectors, as I mentioned previously, are really nothing more than a gateway function, right? So we really don't do any processing on the Z connector itself. All it's doing is encrypting your traffic and sending it to our cloud. Now, why is that important? Why is that kind of cool? Well, the coolest thing about that, or the reason I like it, is you get to offload all of that processing power, all of those CPU cycles, all of those things that would typically be a drain on an appliance, for instance, a traditional firewall. Those processes that would typically be a drain, like data loss prevention and URL filtering, IDS, IPS, firewall inspection, all of that stuff that would typically burn a bunch of CPU cycles and drain the horsepower of our typical appliance. Well, you don't have to worry about that anymore. Instead, these appliances, these Z connectors, act as a gateway to get your traffic to our cloud, and you can put all of that pressure on our cloud. So again, our cloud is purpose-built for this sort of stuff, purpose-built for data loss prevention, purpose-built for IDS, IPS inspection, firewall filtering, URL filtering, sandboxing, all of the cool bells and whistles. You can now offload that onto our cloud and let our cloud handle that for you. Now, again, why is that important? Well, number one, it keeps things operationally scalable for you as an organization or as a customer. Now, think of it this way. Instead of having to put in, many appliances, if perhaps I have a couple traditional firewalls with, several CPUs and several gigs of RAM, and if I turn on data loss prevention or URL filtering, right, or some other advanced inspection technology, I might really drain the CPU on that. And ultimately what that would mean for me is I have to deploy a second firewall, a third firewall, maybe even a fourth or a fifth firewall in order to augment the throughput loss for enabling that feature. Well, again, now I can let my Zscaler cloud take care of that for me. So now the pressure, again, is put on the Zscaler cloud. So I get to keep my gateway footprint, my Z connector footprint, relatively small. Now we're going to talk about things, talk about what that footprint looks like here in just a moment. We'll get kind of into some technical meat of what that actually looks like inside of AWS. But the whole point to this here is you can leverage our cloud for that internet-based protection, and you can leverage the pervasiveness of our cloud and the efficiency and scalability of our cloud. All of that stuff now gets, we take ownership for that now instead of you having to take ownership for it. All you need to do is worry about getting traffic from AWS to our cloud so we can process it. And now with Z Connector, we'll take care of that burden for you as well. We will transport that traffic for you. So from a workload to internet perspective, again, pretty simple use case. Your traffic or your AWS workloads are simply going to forward their traffic to a Z connector that's sitting there inside your AWS subscription. And then that Z connector will forward it to our cloud for whatever security processing you'd like to apply to that traffic. The second use case that is, somewhat of a big use case here recently, especially with the advent of AI, is workload to workload. So, for instance, as I have workloads that are attempting to communicate perhaps cross-cloud or perhaps to an on-premise location in a private cloud scenario or something like that, I might have very, very sensitive data that's going back and forth, and I want to be able to run that data through data loss protection dictionaries or any other type of advanced scanning technology, right? So IDS, IPS, or sandboxing, whatever. There might be all sorts of different tools that I want to run that traffic through. And the Z connector gateway that we just talked about on the previous slide provides that functionality as well. So for those that may be or may not be familiar with Zscaler, we offer our Zscaler Private Access or ZPA platform, which allows for, as the name would imply, private access communication. So anytime you have a workload or a user that wants to communicate with something that is internal to the organization, not out on the internet, but perhaps just internal, that's where the ZPA application would come in, or the ZPA platform. Well, Z Connector, those little blue icons that you see there in each one of those clouds, Z Connector integrates fully with ZPA as well. So it's as simple as forwarding your traffic to the Z Connector. The Z Connector is intelligent enough to intelligently route traffic where it needs to go. Now, there's a lot of intelligence that happens inside our cloud as well. For instance, identifying where the destination of this traffic needs to go. There's synthetic IP addressing that's involved here. All kinds of cool stuff that happens underneath the covers that provides a zero trust architecture for you to prevent lateral movement and whatnot. But again, the Z connector provides that functionality for you for the east-west use case so that you can get traffic from one workload to another workload. Now, speaking a little bit about policy. Now, previously when I was talking, I mentioned that pretty much anything with an IP address sitting in AWS can be secured. Now, I was fibbing just a little bit because that's how most folks know of traffic. Traffic is generally generated by an IP address of some sort. We can track it to an IP address. But in a lot of cases, we can't track things by IP addresses, right? So sometimes we might have devices sitting in AWS that perhaps have overlapping subnets. Perhaps we just went through a merger or an acquisition, right? And we have overlapping subnets, or just in the nature of as we're shifting cloud workloads into the cloud, for whatever reason, we might have, some IP address overlap. And so when we build policy around that, it's very, very difficult to build policy around IP addressing, especially if those IP addresses overlap with other regions or other locations. So how do we get around that? One of the ways that we do that is through user-defined tags. Now, this is a pretty cool feature within our workload protection product suite here. Again, we still leverage that little blue Z connector gateway that you see there kind of in the middle of your screen there. So it's still going to be our gateway to the Zscaler cloud. But what's unique and what's cool about this solution is that Z connector also facilitates user-defined tags. So any tags, and I'm assuming most folks on the call are probably familiar with tags, but just in case you're not, user-defined tags are just an arbitrary value that you can assign to your resources inside of AWS. Right? So if you look over on the left-hand side of your screen there, you can see DevOps. We've got a bunch of tags that are defined in that little bubble on the left side there. Tags such as store_east, app_tier1, app finance, pay internal. These are all arbitrary values that the organization can apply to different elements inside of AWS. So it can apply to a network interface, for instance. It can apply to an EC2 instance, or to an entire subnet, or to a VPC, for instance. You can apply these arbitrary tags wherever you see fit, and then you can use these tags inside of Zscaler policy. So when it comes to creating that granular policy, I no longer am strapped to having to use an IP address. I can now use these tag values. So as you create tag values as an organization inside of AWS, those tag values will automatically propagate through those Z connectors and on up into our cloud and make them available inside your internet policy and even your Zscaler private access policy. So you can start creating very, very granular policy around those arbitrary tags and never have to look at an IP address again. Right? So it makes things very, very operationally efficient for the organization. You're no longer really concerned with IP addressing and things like that. It also makes things very easy to read. When I'm looking at policy, a lot of times it's easier to read a tag than it is an IP address. A lot of times IP addresses don't tend to have very much context around them, but at least with a tag, I can get a lot of context around what this machine is doing, what group it's a part of, what type of traffic profile it might have, all of that good stuff, right? So the user-defined tag feature is a really, really powerful feature that we see a lot of our customers using within AWS. And it's something that you can definitely leverage our cloud to help you in terms of implementing a granular zero trust security policy. Now, what about performance and scale? So we talked about this just a moment ago. The big Uno card here, so to speak, is our cloud. Right? You can leverage our cloud for most of the heavy, intensive security processing that you might need to do as your traffic is traversing from workload to workload or workload to internet. But, you might be asking yourself, okay, well, that makes sense. But what about the Z connectors themselves, right? The Z connectors themselves, they have to have some form of, some limit, right? There has to be some limit to the amount of traffic that they can send to the cloud and that sort of thing. How do we handle that sort of stuff? Well, we have partnered with AWS and we've worked with AWS rather extensively to build in things like support for gateway load balancer and support for the auto scale functionality, right? And so the idea would be here, as your organization, when you deploy the Z connector or the workload protection solution, you perhaps, as a best practice, you might deploy a few Z connectors, maybe one or two in each availability zone, or 2 or 4, depending on what your resilience needs are. But after you deploy those appliances, looking forward, if the organization ever runs into a situation where perhaps you see a spike in traffic, or perhaps you see just a large influx of traffic, and that traffic needs to be sent to our cloud, that's where we can leverage something like AWS Autoscale to automatically grow your Z connector cluster to handle that large influx of traffic so that we can get that traffic to our cloud effectively. And then as that traffic starts to subside and cool off a little bit, we can automatically decommission those appliances for you and get rid of those Z connectors so they don't use any unnecessary CPU and RAM and instance types within AWS, and try to keep that cost low for you on a month-to-month basis. And we leverage things like a GWLB, Gateway Load Balancer, to automatically distribute the load across all of those appliances, whether they are auto-scale appliances or whether they're permanent appliances that never get decommissioned for any reason. But Gateway Load Balancer provides that high availability aspect, but we use cloud-native functionality here in order to maintain the optimal level of scalability and performance for you. So in a nutshell, what are we? What's Zscaler Workload Protection? What's it all about? Again, it's about leveraging our Zero Trust Exchange, our purpose-built security cloud, that is pervasive around the globe to protect your AWS workloads. How do we do that? We do that with Z-connector appliances. We put those appliances, those gateways inside your AWS environment or inside your on-premise location. Those Z-connectors facilitate workload to workload or east to west use cases. They also facilitate workload to internet use cases, so north to south use cases. So in situations like that, again, you're leveraging our cloud for most of the processing that happens here. So things like SSL decryption, TLS decryption at scale, all of that stuff happens now in our cloud. So you really get the best of both worlds here. You get things like inline data protection, IDS, IPS, firewall protection, all of the bells and whistles that you would expect on a advanced next generation security platform. All of that exists within our cloud, and you get to take advantage of it through Zscaler Zero Trust for Workloads. Now, for the technical folks in the room that are there, might be asking yourself, what does this actually look like? How do you actually deploy something like this? I've got several AWS accounts, for instance, or several AWS subscriptions, and what might this look like in one of my AWS accounts? Well, I got a couple examples for you, maybe just to kind of show what this looks like from a technical perspective, so you can get an idea of how you might insert workload protection into your environment. So the first one here is the co-located model, as I call it, or the direct to internet model. So as you can see here, those little blue icons in the middle of your screen, which they say CC, right? So formerly known as Cloud Connector, we call them Z connectors now. These Z connector appliances are right there in the middle of your screen. You can see that they are front-ended on the left-hand side there by the gateway load balancer functionality. So each of our workloads and each of our availability zones on the left there are simply going to route their traffic through the gateway load balancer and on into one of those Z connector appliances. Those Z connector appliances are automatically going to then send that traffic out to the Zscaler Zero Trust Exchange for processing. Again, the Z connectors are intelligent. So as the gateway load balancer is sending traffic across all four of those appliances, each one of those appliances is doing its own intelligent lookups to find out where's the nearest Zscaler data center that I can go connect to, which one is the best performing right now, right? Or perhaps if we're having issues at one of the data centers, which one can I transition my traffic over to get this user a better experience? All of that intelligence is happening within the Z connector appliance there in the middle of your screen. So this is what it might look like if I was going to deploy those Z connectors inside my application VPC. So really, really close to the end workloads or to the workloads that it's going to service. But you might be asking yourself, oh, okay, well, that works, but I've got dozens, if not maybe hundreds, maybe thousands of VPCs. What does that architecture look like? And so that architecture, typically, you might refer to that as a hub and spoke architecture, but for the folks that are very keen on AWS in the room, you might know it better as Transit Gateway or TGW. So in a Transit Gateway or TGW approach, it's pretty simple. We're still going to deploy our Z connectors, but we're going to put them in their own little island by themselves. And that little island is kind of our you can think of it as a service VPC, some people call it, or an egress VPC. I'll stop short of calling it a transit VPC, but as they used to be called in the SD-WAN days. But think of it as a dedicated island of Z connectors that we can forward traffic to, and then have those Z connectors process that traffic, whether they're going to send it off to the Zscaler cloud or whether they're going to send that traffic locally to another workload wherever it needs to go. But the idea here is I can have dozens, hundreds, thousands of VPCs, multiple subscriptions that are all connected to a transit gateway. And then I leverage Transit Gateway to aggregate that traffic for me and send it to the Z connectors in the island on the right-hand side there for processing. So with that, I appreciate the time. Keith, I'm sure we probably got a few questions here. I'm going to hand it over to you. Maybe we can answer what's on the mind of some of these folks.
Yeah, absolutely, Aaron. Thank you so much for that great presentation. Both you and Henning had some awesome information and education for all of us. And we do have some questions coming in. So let's get to those. I have several for you, and then I also have several for Henning. So let's start with you, since you just finished up. Now, you talked about this some, but maybe you can dive in a little more, because someone wants to know what differentiates Zscaler when I determine what security solution to leverage on AWS.
Yeah, good question. So, I probably don't want to beat a dead horse here because I talk about this too much, but what really sets Zscaler apart is our cloud, right? We have a purpose-built cloud that is designed for security. Now, why does that matter to an organization? Well, it really boils down to the fact that, again, you can leverage our cloud to handle some of those advanced security tasks that would normally drain traditional appliances. All right. So if I look at, a really expensive appliance that I would have, typically used to handle data loss prevention and, URL filtering and all that stuff, the minute I turn on SSL decryption or TLS decryption, or URL filtering or data loss prevention, the minute I do that, I'm going to take a pretty huge CPU impact, right, and a RAM impact. And we talked about this towards the beginning of the presentation, but sometimes that's a lot to swallow, right? Because a lot of times what it means is I might have to overspec a firewall. I might have to overspec my appliances because I know I'm going to turn on features that are going to take a lot of resources away. With Zscaler, you really don't have to worry about that, right? You just simply deploy the Z-connector appliances and you let our cloud take care of that. So you can turn on SSL inspection or SSL decryption. You can turn on data loss prevention. You can turn on URL filtering, anything you want, sandboxing, and it has no detrimental impact to your organization in terms of things like latency or overall throughput. It really doesn't matter because we have purpose-built hardware. We have purpose-built software sitting on that hardware inside each one of our data centers to handle that for you. So really, again, it's our cloud that makes us the biggest differentiator. But that, what that boils down to for an organization is that gives you a more consistent security policy, right? You have a single, dashboard that you visit, for workload to internet or Zscaler private access. You've got a single dashboard, so very consistent security policy, very consistent from an operational perspective. These Z connectors are the same, whether it's in AWS or your on-premise locations, or any other cloud for that matter. It's the same architecture and it's the same security policy across your entire organization, including users and IoT devices. So it really boils down to saving you a little bit of money on the fact that, hey, you get to leverage our cloud, you get to leverage a very consistent security policy all across the board. So it makes things super efficient for you. So
yeah, it does, and I would add here, Aaron, that baked in is better than bolted on. I mean, you mentioned purpose built, and that is just so important. You can bolt it on, but it tends to be kludgy and things get missed, as we all know. So that is really nice to hear. Okay, next up for you. How do I determine the best deployment strategy when leveraging workload communications?
Yeah, I kind of figured that one might come. So, it really depends. You saw on the previous couple slides, two different options inside of AWS. And one thing I want to make clear is there is no one size fits all. In fact, we have a lot of customers that they like to mix and match, right? So typically one thing I like to tell my customers is, if you're going to deploy workload protection, Zscaler workload protection, you're going to put in Z connectors. The architecture you choose, a lot of times it boils down to number one, what features are you going to take advantage of with Zscaler, but also how granular do you want your security policy to be? And what I mean by that is, if we look at typical best practices when it comes to security, what's security best practice say? Well, security best practices say that we should put the enforcement device, whether that be a firewall or a Z connector in this case, we should put that device as close to the source of the traffic as we can. So that way, if there's any offending traffic that comes out of that workload, we can drop it right away, right? It's not going to tie up the wire. It's not going to make it to the end destination. We can drop it almost instantly. Now, one of the slides you saw was a co-located model where we put those Z connectors inside the same VPCs that we have our applications residing in. A lot of customers might choose to go that route simply because it puts the Z connector appliances very, very close to the source of the application. So it makes it very easy for me to create very granular security policy and be very specific about where those applications and workloads are allowed to go. However, if I've got dozens and dozens of VPCs, right, I don't want to go deploying a whole bunch of Z connectors and all these different VPCs, just like any other device. That's a lot of VMs to manage. I may not want to do that. And so that's why we have a transit gateway or a hub and spoke model where you can put those Z connectors in a hub or kind of an aggregate area, and then use something like transit gateway to push traffic through that aggregation device or through that aggregation VPC where the Z connectors live. Now, we have customers that take a hybrid approach, right? So as I said previously, there's not a one size fits all here, but we have customers that will take a hybrid approach where you might have very, very sensitive applications that you want to be, very, very cognizant of and very, very specific about how you route and secure their traffic. You might decide to put Z connector appliances very, very close to those applications, right? And then for everybody else, perhaps you leverage the transit gateway model or the hub and spoke model, and everybody else is going to flow through transit gateway and on up into a services VPC where we've got some Z connectors sitting where we can process that traffic. So it's really hard to answer, in a quick 60-second answer here, but it kind of all depends. And I would highly encourage you maybe to take contact your Zscaler account team, maybe take a test drive of Zscaler Workload Protection on AWS. We have a lab available, so you can actually get some hands-on time and see what it looks like to generate some traffic inside of AWS and see what Zscaler can do to protect it.
Great. It's always nice to have lots of options for how to set it up, and put it together for something that can get pretty complicated. Okay, let's move on to some questions for Henning. We've got some good ones coming in, so I want to get going with those. Henning, first up for you in this session, what best practices for logging and monitoring should be considered when implementing Zero Trust on AWS?
Yes, thank you very much, Keith, and also Aaron for excellent information there. Very much appreciated. But I was hoping that this question would come up. Very good question. When I think of some of the logging and monitoring best practices from an AWS perspective, look, I work with customers all day, and most of them have workloads that are being deployed either in multiple accounts or multiple regions, perhaps, right? So number one best practice I normally point to is that of centralization, simply because who wants to go and visit every region to go and get a full picture of logging and monitoring, right? So centralization, I believe, for monitoring and logging is key. For that, we can use services such as Amazon CloudTrail, VPC flow logs, DNS query logs, and other services to capture a comprehensive view of all this activity. You can also integrate logs from on-premises environments and workloads that are running on-prem for a holistic view. So that of centralization is key. I would also point to making sure that the logs are being stored in separate S3 buckets. S3 buckets offers enhanced security by preventing attackers from deleting or corrupting all of your log data in one go. So it minimizes the blast radius. And then making sure that all of that information is encrypted using something like AWS KMS or Key Management Service, both in terms of in transit as well as in rest. So we want to make sure that that is encrypted as well. Some additional considerations when it comes to logging and monitoring is automation. This is something that we have touched on. Also, automating these processes minimizes manual effort. And it also ensures timely detection of potential threats. Also want to point out to be aware of some of the log retention policies that are in play. Make sure to establish those policies early on and make sure that they are being monitored and implemented. And then lastly, Keith, I would say that promote a culture within your organization of security awareness. And that's something that we have been excellent with over at AWS. So educate your teams on the importance of logging and monitoring in a zero trust environment.
Great stuff. And I want to mention here before we get to the next question, just for clarification, because some people still don't know that zero trust is not a product; it is a mindset. So let's keep that firmly in mind as we are discussing this, because this next question, Henning, also relates to zero trust, and that is this: how can I leverage AWS services to achieve continuous improvement in my zero trust implementation?
Yeah, excellent, Keith, and thank you. Yes, that is a very important point to keep in mind, that zero trust is not a product or a service, that it is a methodology, perhaps a conceptual model for implementing network security. But in terms of some of the AWS services, there are some AWS services that offer excellent built-in zero trust features. And you're going to be surprised, but some of them are very native to AWS and very basic. But I'll point to IAM as an example, the identity and access management. And it's simply because it provides granular access controls to your AWS resources. And it sounds familiar in the world of zero trust, granular access control, right? That is in line with what we see in the zero trust world as well. And make sure to use features like least privilege, multi-factor authentication, and user activity monitoring to strengthen the identity controls. Another control security service from AWS that I would point to is that of VPC, the Virtual Private Cloud. VPCs allows you to create a logically isolated network for your AWS resources and implement security groups to control inbound and outbound traffic within your VPC. And Keith, the last one I want to point to is not so much a control, but it's that for monitoring, storage, and analyzing of log data, and that is Amazon Security Lake. And Security Lake automatically centralizes security data from the cloud, on-premise, and custom sources into a purpose-built data lake stored in your cloud environment inside your VPC. So that's all I have, Keith. Thank you so much.
Great. I think that Henning, one of the real strengths of AWS is the large variety of features and services and things, so that you can tune it so specifically for whatever environment you have, no matter how much data is out there and where it is and all of that. AWS has an answer for it, and that's just one of the things for me that always stands out. And so I think that about wraps it up for us today, gentlemen. We are approaching our time here, but I want to thank you, Henning and Aaron, for educating us on what AWS and Zscaler are doing up in the cloud now. So much innovation going on, and your companies are some of the leaders in this space, in the innovation and in keeping us safe up there in the cloud. So I want to thank you both for your time today and for your answers and insights for the presentation. It was just a real delight to have you on.
Thank you very much.
Yeah, thank you.
Okay, everyone. Great stuff. I noticed that Aiden, one of the attendees, left a comment a little while ago, learning quite a lot, and I have to agree with him. Just terrific information throughout that presentation today. Great insights in the Q&A, and it was just a lot of fun for me. So that ends the presentation, folks. But before we wrap up and let you go today, we do have one more piece of business, which is the Amazon gift card prize drawing. As I mentioned up top, we are giving away a $250 card. And as always with our events, you do have to stick around for the whole event to be eligible to win. And we do have a winner for today, and that winner is Nitish Singhal from Massachusetts. Congratulations to you, Nitish. We will be in touch ASAP to get you your card, so please sit tight. And with that, everyone, we are wrapped for today. On behalf of the Actual Tech Media team, I want to thank Zscaler for making this event possible. And thank you, attendees, for being here, for your great questions. We are out of time. I will see you in the next one, folks. That concludes the event. Have a great rest of your day.